Good afternoon, everybody. Welcome to this RayTech CPD webinar. This is the first of our CPD certified webinars that we're going to be running. My name is Andy Oliver. I'm National Sales Manager for the UK and Ireland, and I will be presenting today's webinar to you. I will be joined later on by Barry Thompson, our Director of Hazardous Area, who will be assisting me in the question and answer session towards the end. So please note, if you do have any questions, you can submit these into your GoToWebinar control panel, and then we'll look at those at the end of the session. So, hazardous area certification and the importance of it. So, the agenda is an introduction to hazardous areas, hazardous area classification, an overview and the importance of certification, products, standards, and also looking at the nameplate. We'll briefly look into self-certification, the overview, the reasons why, and associated risks. And then we'll look at choosing the correct luminaire in relation to certification and classification. And then we'll have some questions and answers at the end. So, introduction to hazardous areas. What is a hazardous area? Hazardous area is any place in which an explosive atmosphere may occur in quantities such as to require special precautions to protect the safety of workers. And specialist lighting plays a critical role in safety and efficiency in such hazardous areas. Now, I said any place in which an explosive atmosphere may occur. So this is these sort of locations are, just to name a few, not few, oil rigs, refineries, chemical productions, petrochemical, food processing, and there are lots of other less obvious applications that require hazardous area equipment, but it is important to know when and why this type of lighting is required. So why is hazardous area equipment required? So equipment, including lighting, so not just lighting, anything that's used in a hazardous area environment, needs to be purpose designed for use in hazardous areas to prevent an explosion from occurring. For an explosion to occur, there are three components that need to be present. Flammable substance, which is often the actual process that is going on in the facility, oxygen, and the ignition source. So looking at the flammable substance, this needs to be present in a relatively high quantity to produce an explosive mixture such as gas, vapors, mists, or dusts. Oxygen is required in high quantities and in combination with the flammable substance to produce an explosive atmosphere. Now, oxygen exists in the air we breathe at about 21%, and this is a suitable quantity to produce flammable produce an explosive atmosphere. And finally, we need an ignition source. So a spark or high heat must also be present to ignite the mixture of flammable substance and the oxygen. Now, there are 13 potential ignition sources, such as flames, hot surfaces, mechanically generated sparks, and static. They're just 4, but a greater list is available to research and look at. So together, these three components make up the fire triangle. Take any one of these away and the potential is removed. Now you look at that in more detail. Removing the flammable substance means shutting down the work process, which is often unrealistic. Removal of oxygen is generally not going to happen either unless it's a pressurized system. So ultimately, we are looking to remove the ignition source. Now, when we talk about, that was about gases and vapors, when we talk about dusts, there are an additional 2 components that need to be taken into account. Confinement, such as the building in which the operation is taking place, and dispersion, which is the quantity of dust in the air within the confined space. But as per the fire triangle, take any one of the 3 critical items out of the equation and there is no risk of an explosion. So why EX lighting? So explosion-proof lighting. This means the luminaire will be able to either prevent sparks from occurring or to contain them in order to ensure it cannot be exposed to the flammable substance in the air and to prevent an explosion. EX lighting is often required for many areas throughout the site, including internal manufacturing areas, clean rooms, internal and external access, as well as storage areas. So one example of where gases and dust can be dangerous in the workplace is in pharmaceutical manufacturing. And the images you can see on the screen now, the left-hand image is the exit point of a production building, just to qualify that an explosive area can exist outside of the production facility. And the second image is the actual production area, which shows some EX-rated clean room lighting. Although it may not be one of the first industries which come to mind when thinking about typical uses for hazardous area equipment, large parts of modern pharmaceutical facilities are classified as zoned hazardous areas. And this is more often than not due to the raw solvents, chemicals and gases which are used during or generated during the manufacturing process, powders, dusts and gases produced as a byproduct of the manufacturing process, and storage of materials and gases on site for use in the manufacturing processes. So, looking at hazardous area classification. In order to protect areas from potential explosion, a method of analysing and classifying a potential hazardous area is required to ensure the correct selection and installation of equipment. This can vary across the world, but generally speaking, there are two main types of classification. For countries that have adopted the IEC format, this is referred to as zoning, whilst in North America and Canada, it is classified by classes, divisions and groups. But for the short term, we'll be focusing on the IEC classification system. So there are three types of hazard. Group 1 is mines or underground applications susceptible to fire damp. Fire damp is another term for methane mixed with air in underground mines. But the two most popular groups we come across are groups 2 and 3. Now these are both above ground installations. Group 2 is for explosive gas atmospheres and group 3 is for explosive dust atmospheres. These groups are then further subdivided into gas groups. So for group 2 for gas, we have groups 2C, 2B, 2A. This is related to the spark energy required to ignite the gases. This is called the ignition energy. So a gas group 2C, or a gas that lives within group 2C, requires the least amount of energy to cause an ignition, such as acetylene or hydrogen. And the requirement here is around 18 microjoules. On the contrary, a class 2A gas requires the most energy to cause the ignition, around 260 microjoules. In here, we have vapors such as propane and petrol vapors. So there is an order towards these groups. Equipment certified to gas group 2C can be installed in areas where there is gas groups 2B or 2A, but equipment in gas group 2A cannot be installed in gas groups 2B or 2C. Similarly, as we had for gas, the exact same principles apply for dust, but the naming is slightly different, in which case, in this case, it's dust groups 3C, 3B and 3A. So 3C are the most volatile, combustible and conductive dusts, such as magnesium, down to group 3A, which is ignitable fibres and fly-ins, such as cotton lint, rayon, and flax. As well as ignition energy, we also need to take into account ignition temperature. And this is defined as the temperature at which a substance can ignite and sustain combustion without being initiated by an external spark, flame or heat source. So as an example, hydrogen has an ignition temperature of 560 degrees Celsius, So therefore it would be classed as a T1 class gas, whereas at the other end of the spectrum, carbon disulfide has an ignition temperature of 90 degrees Celsius, so it would be classed as a T6. So importantly to notice here, any piece of equipment that is certified to T6 can be installed in any of the T groups, T1 through T6, whereas a T1 piece of equipment can only be installed in a T1 classified atmosphere. So looking at zone classifications. So every application is different, and for the ease of monitoring and specification, each hazardous area is classified as a particular level or zone. Zones define the type of explosive atmosphere, as well as the likelihood of an explosive atmosphere being present. The risk also depends on how long the hazard is present, and as a result, all hazardous area equipment must be designed with the hazardous area zone classifications in mind. As the zone governs the level of protection and precaution required, it is essential to know which zone you are working in so that you can specify the most appropriate equipment for gases, vapors, mists and dusts that are present in these zones. And in these zones, this is subdivided into 3 zones. So we have zone 0 and zone 20, which is EPL category 1. EPL is an abbreviation for equipment protection level. So zone 0, zone 20 would be classified as an explosive atmosphere which is present continuously or for long periods of time, greater than 1,000 hours per year. Zones 1 for gas, 21 for dust is EPL category 2, and this is where an explosive atmosphere is likely to occur in normal operation and generally for periods between 10 and 1,000 hours per year. And the least hazardous of these areas is zones 2, 22, EPL category 3, and this is defined as an explosive atmosphere not likely to occur in normal operation, but if it does exist, it will be present for short periods only, generally only around 10 or fewer hours per year. So what zone do you need? So taking a look at this example of a hazardous area and the different zoned areas on one site. So here we have a petrol tanker and the underground tank where the fuel is stored at the petrol station. You would always expect there to be fuel present in these areas, so this is classified as zone 0. The hazard is always present. Looking outside of that, you have zone 1. So this would be the release point and the entry point, or the release point from the tanker, the entry point to the underground tank, and the release point around the petrol nozzles at the actual filling station. This would be classed as a zone 1 area. The hazard is likely to be present during normal operation. And zone 2 exists in a radius outside of the zone 1 area, and here it's outside of the tanker, above the vehicles, underneath the canopy, and here it's the area it's unlikely to be present in normal operation. Knowing which zone you need can be a challenge, and this is because every application is different, as I mentioned earlier. The site needs to be independently classified to determine things such as the types of gas and dust present and in what volume, plus also the level of ventilation on site. Ultimately, it is always recommended that hazardous area classification needs to be done on site by qualified personnel and applying the relevant standard 60079-10. Moving on to the North American and Canadian standards, that is done in a slightly different way, and that they use classes, divisions, and groups. So here, the class defines the general nature or properties of the hazardous material in the surrounding atmosphere, which may or may not be in sufficient quantities. So you have class 1, locations in which flammable gases may or may not be in sufficient quantities. Class 2, locations in which combustible dusts may or may not be in sufficient quantities. And class 3, for fibres and flyings. This is then subdivided into Division 1 and Division 2. The division defines the probability of the hazardous material being able to produce an explosive or ignitable mixture based upon its presence. So Division 1 indicates that the hazardous material has a high probability of producing an explosive mixture due to it being present or from the equipment itself under normal operating conditions. And Division 2 indicates that the hazardous material has a low probability of producing an explosive or ignitable mixture and is present only during abnormal conditions for a short period of time. Now, looking at the IEC zonings and North American classes and divisions, there are some similarities, but the two are distinctly different and you shouldn't confuse the two. Gases and dusts in the North American system are then further subdivided into groups A, B, C, D, E, F, and G. So, looking at product certification. There are different product certification schemes and standards, and strict certification requirements exist for any equipment being installed into hazardous areas. There are several different certification authorities that exist in relation to hazardous equipment, and those relevant to you will depend on where the products are being installed. This ensures that lighting and other equipment do not present a safety risk and is compliant with the necessary regulations. To obtain this certification, the luminaire or equipment must generally be tested and approved by an independent third-party body, and this is called a notified body. And in the next few slides, we will go into the finer details of these different certification bodies. IEC-EX is the certification system based on IEC 60079 standards for electrical equipment use in hazardous areas. So IEC-EX is an internationally accepted means of proving compliance with IEC standards. And certification is carried out by an approved certification body, also known as an EXCB. So you should also look out for the EX, CE, and UKCA logo, along with the IEC-EX certification data, which the manufacturers should publish on their website. Well, given that IEC standards are used in many national approval schemes, IEC-EX certification can often be used to support any specific national compliance which is required, negating the need for additional testing in most cases. Now, in addition to this, there is an IEC database. So the IEC-EX database is used by a lot of people as it allows you, the public, to view the certificates of any product that has been registered for use, not just lighting. It includes a variety of products with a hazardous certification, such as power supplies, stopping plugs, cable glands, all types of equipment that are used. This means that customers can corroborate and validate the certifications given to them by a supplier. Manufacturers must be assessed by an EXCB, notified body, and they are then issued with a quality assurance report, or QAR, which allows them to sell and distribute certain types of IEC-EX approved equipment. So moving a little bit closer to home, we have the ATEX directive. So the ATEX directive is the European certification that is mandatory across Europe and is based on the IEC 60079 series of standards. Now, like IEC-EX, ATEX involves all stages from the manufacturer through to installation, use and maintenance of the equipment. Companies must fulfill the ATEX requirements to be able to manufacture, import or distribute EX equipment within the European Union. And certified equipment must be marked with the EX logo, the hexagonal yellow hexagon with EX in the middle, as shown above. The logo should also be included on the product nameplates of the physical product, and the manufacturer should publish ATEX certification data on their website. To manufacture products intended for use in potentially explosive atmospheres, manufacturers must be ATEX and IECEx compliant. Compliance issued by a notified body is required to ensure the manufacturer is authorized to produce and sell hazardous equipment. As with all other electrical equipment placed on the EU market, irrespective of whether it's hazardous or non-hazardous, it has to carry a CE mark. This shows compliance with all European directives, including ATEX. And finally, manufacturers have to be assessed by a notified body, but that notified body must be based in the EU, and then they are issued with an ATEX quality notification, or QAN, Q-A-N. So you'll often see on many manufacturers' websites, you'll be able to download a QAN and QA certifications. Now, let's look at UKCA. Now, following the UK's departure from the European Union in January 2021, the United Kingdom Conformity Assessment, UKCA mark, which is the UK Conformity Assessment, was planned to replace CE marking and declares that the product conforms to the applicable UK legislation in order to be placed on the market in England, Scotland and Wales. However, due to the Northern Ireland Protocol, goods in Northern Ireland will continue to require CE marking, or in certain particular cases, a UK NI mark. Now, UKCA affects all products subject to the EU directives that used to require CE marking. So this is radio equipment, EMC directive, low voltage directive, and these cover a huge number of different products. Again, not just lighting. In the case of hazardous area equipment being installed in the UK, the ATEX directive was going to be replaced by UKCA, and the UK directive, SI 2016-1107, a UKCA EX scheme known as UKEX. And in addition to the notified body and QAN issued under the ATEX directive, a separate UK-based approved body and a UK QAN must be applied to products under the UKEX scheme. Now, you may have noticed in that last slide, I used the word was more than once. In 2023, the government declared an indefinite extension for businesses to utilise the CE marking instead of using the UKCA, making ATEX a valid alternative marking to employ as well. So basically, any product that has an ATEX mark on it can be used within the UK, but also always look out for UKCA or UKEX and ATEX to be on the safe side. So looking at protection standards and equipment protection concepts according to IEC 60079, all of these have their own standard. 60079 0, 1, 2, 5, 6, 7, 11, 15, 18, 31, and these all relate to the type of protection concept that a piece of equipment is designed to. So, for example, EXD to 60079-1 is classed as flame-proof enclosure. So EXD luminaires approved to this standard must be able to safely contain an explosion and the accompanying pressure that develops. They must prevent any fire or sparks from escaping the enclosure and into the surrounding explosive environments. This protection method, therefore, is focused on containment rather than prevention. Conversely, EXE luminaires, so to 60079-7, luminaires approved to this standard are designed to be cool running and prevent arcs, sparks and hotspots from happening in the first place. So in short, this protection method is focused on preventing the risk of explosion by ensuring an ignition source can never arise. Moving back to North America, so you have Class 1 or C1D1, Class 1 Division 1 and Class 1 Division 2. So unlike most countries, Canada and the United States do not base national compliance for hazardous area products on the IEC 60079 series of standards. Instead, a separate range of UL or CSA for Canada, standards exist which the equipment must comply with. The MET mark, so MET is the notified body that RATEC use for product in Canada and the United States. So the MET mark indicates that the product has met the minimum requirements of the applicable safety standards. And additionally, the MET mark validates the product's continued compliance to these standards as experienced by periodic factory follow-up inspections. The circle, which you can see, contains a certifying agency identity, product safety certification in North America. The C outside the circle indicated the product was certified by Standards Council of Canada, accredited certification body, and the US outside the circle indicates the product was certified by an OSHA approved NRTL for the United States. For other countries outside of the jurisdiction of the above covered regions, i.e. Canada, North America and Europe, additional local requirements may also apply. However, in most cases, these tend to be based on the IEC EX certificate and is unlikely to require further testing. An example of this could be the in-metro system in Brazil. So, moving on to equipment nameplates. An EX luminaire, or for that matter, any EX piece of equipment, the nameplate provides valuable information about the equipment and it allows you to identify the manufacturer, the areas in which it's safe to be used, as well as key information about the luminaire or equipment specification. So, looking at a RATEC nameplate, so information about the luminaire specific information about the luminaire specification includes input voltage, ingress protection rating, and a lot more besides. For installers and end users, this information is critical to ensuring the luminaire is installed correctly and safety on site is maintained. So to understand the different information on a nameplate, or a nameplate tells us, we'll now look at the information or the points you can see on the slide, and this has been installed on a mid-power Spartan floodlight. So starting number 1, top left corner, you have the name and address of the manufacturer, in this case RATEC, Ashington, UK. Point 2, you have the WE logo, which is the responsibility, ensures responsibility for the product to be disposed of in a responsible manner. Item 3 is the UKCA marking and the identification number of the notified body appropriate or responsible for monitoring of the quality system. And number 4 is the equivalent CE marking and the number identifier of the notified body responsible for monitoring the quality system. Item 5 is a description of the certified equipment. So in this case, MP mid-power Spartan LED luminaire. Number 6 gives certificate numbers of the certified equipment for ATEX, IECEX, and UKEX. You may note some equipment may end in a U for component certification, or it may end in an X, meaning that certain special conditions apply for safe use. We'll go into the X in another slide. Point 7 details ambient temperature range for certified equipment and its safe operating temperatures. Item 8 details the gland and thread entry size. Item 9 on the bottom details the serial number of the equipment, including a year of manufacture. So in the instance here, you have the year of manufacture, you have 2410. So for us, that would mean 2024, week 10. Item 10 gives you the specific part number of the equipment in question. Item 11 gives you any other essential information required by the standard. Item 12 details the voltage and power consumption. Item 13 goes into detail about ingress protection ratings. Obviously, the first number is against ingress of solid objects, and the second number details the ingress protection of water. And finally, number 14, the explosion protection marking for ATEX. So in this instance, we have equipment group 2, which means above ground, and category 2, which means it's zone 1. The type of explosive atmosphere, gas and dust. in this instance, we have a GD, and followed by the protection concept. So in this instance, we have EXEB. So EXE, as we mentioned earlier, is by increased safety. B is for gas groups to that certification. MB is the additional protection concept. So M is by encapsulation. And then continuing on, we have the gas group 2C and the temperature class classification T4. So I mentioned in that previous slide about an X on a certificate, and I'm sure at some point you will have seen an X on a certificate number. And it's important to know why an X might be used and to look out for the X symbol. It identifies that there is a specific condition, whether that is to do with installation, use, or maintenance of equipment, that should be considered when using the equipment in hazardous areas. So you look out for an X at the end of the certificate number of the certified equipment. Certificates, as well as installation guides and manuals, must include explanations of what the X are. Now, an X symbol does not automatically mean something bad. It could be something simple as how to clean the equipment safely, but it is important that this information is shared and understood to ensure that the equipment is safe to install, use, and maintain in a hazardous area. So we'll now move on to self-certification. So what is it? Self-certification is a widely accepted principle within UKCA and CE marketing. Manufacturers are asked to declare conformity to the relevant directives and applicable standards for their products. And a technical construction file must be created and maintained by the manufacturer and made available to authorities if required to prove compliance. Now, there are limitations and associated risks with self-certification. There is no scope whatsoever for Zone 1 products to be self-certified. These must be by a notified body and have QAN and QA certifications. This exists under IECEX and North American standards UL and CSA. Under ATEX, it is accepted for Zone 2 only because of the level of risk in the application and the potential consequences if it goes wrong. So for Zone 2 products, no involvement by a notified body. All manufacturers declare conformity to the relevant standards when placing product on the market. So, things to think about when looking at self-certified product. Has the design been fully assessed against the requirements of the standard? Are they using the latest version of the standard? Some of you may know that EXNA is no longer a valid protection concept and has been replaced by EXEC. Have they missed any small details which might be critical? What about continued quality and surveillance of the supply chain and the manufacturing process? What about liability for the distributor? In the EU, they are effectively and legally responsible for the product in that market. So they need to know that they are sure they are getting something that is safe for use. Our advice: the safest and most straightforward option for the end user is to choose a luminaire that has been certified by a third party. And this is the approach we take at Raytec. We never self-certify our Zone 2 luminaires. All of our products are independently tested by a third party, without question. So, choosing the correct luminaire. So why certified LED lighting? ATEX is not the only factor we have to consider. Certified LED lighting is essential for safety and quality, but as I said, there are other factors. Luminaires must also meet other important directives, such as the Low Voltage Directive, Electromagnetic Compatibility Directive. Certain products will need to comply with the Eco Design Requirements Directive, and then additionally there is REACH and WASH directives for the reduction of hazardous substances used in the manufacturing process. So the Raytec approach, how we approach certification: every product certified to the very latest standards. And at Raytec, we prioritise independent testing for our luminaires, ensuring reliability and safe operation in hazardous area environments. So, in summary, to recap, when specifying equipment for use in hazardous areas, end users should choose equipment based on the specific requirements of the site. It's important that end users are aware of these key considerations when specifying. 1. The zone you are specifying in, so you can specify the most appropriate equipment. 2. Where the products are being installed and the certification requirements to ensure the product is compliant with the necessary regulations. 3. The method of protection used during certification, so you are clear how the luminaire has been designed and will need to be maintained. And 4. The type of hazard to identify the risks of ignition and the severity of any potential explosion, allowing the correct selection of equipment for that particular specific hazardous area. So following this general rule of thumb, when specifying your hazardous area equipment, you can generally rest assured that the site is protected to the highest possible standards. So ladies and gents, that concludes the presentation of the slides. We'll now take any questions that you may have, and for that I will invite Barry Thompson to join me on the presentation, and he will answer any questions that you care to submit. I will point out at this point, if you require a CPD certificate, please email us at the address shown, marketing@raytecled.com, and we will provide that certificate in due course. Copies of the presentation and the slides are available, and these will be emailed out to you on request. So if you have any questions, I will take those now. Right, first question we have. Are you seeing much in the way of fake equipment coming into the market?
In answer to that, we regularly see probably every 3 months a fake certificate. So normally when we look at a certificate, we can tell fairly easily it's a fake. ATEX certificates are a lot more difficult to detect because you don't have an open source database, whereas IECX certificates, you can always check the certification on the IECX website and make sure that it is genuine, but it is a growing problem within the industry. So if in doubt, ask.
Thank you. What is the minimum rating? What is the minimum IP rating for ATEX equipment for Zone 1?
So any ATEX equipment has to have an IP rating of IP54 as a minimum. For all Raytec products, all of our products are generally done to IP66 and IP67 to make sure that they're rugged enough for any situation they find themselves in.
Thank you very much. Another question just landed. A note in the nameplate slide, I saw reference to EXTB. Could you clarify what the B stands for, please?
I'll probably need to come back to you on that one. I don't want to give any wrong information, so I will come back to you on that one just to give a full explanation. Okay, thank you very much. That completes all the questions at the minute. We'll just see if anything else lands, so just bear with us a moment. Here's a question. Who is responsible for classifying an area so suitable lighting can be provided? To classify a hazardous area, you would need to either have a qualified person on site, or you would need to get a consultant who specialises in classifying the hazardous area. As a manufacturer, we're not allowed to say whether a hazardous area is Zone 1 or Zone 2. That information needs to be provided to us. Now, there is specialist organisations that we work with, so if anyone is after some guidance, please feel free to email us.
Thank you. Another question regarding the nameplate slide I put up earlier. In the luminaire nameplate shown had IP66 and IP67. Can you please clarify why the two ratings appear in the nameplate?
The reason we have the ratings, the IPX6 and the IPX7, anyone who has seen IPX testing, IPX7 is underwater for about half an hour, and there has to be no water ingress into the luminaire. IPX6 is a very, very high pressure hose, and some people feel that IPX6 is more onerous than IPX7, and there has been situations where an IPX7 luminaire will fail an IPX6 test. To get around all these arguments, as standard, all of our luminaires are tested at IPX6 and IPX7. So whatever the application and the environment, you know that's not going to let water in.
Super, thank you very much. Questioning from Trevor. Do you see any interest for equipment certified for North America zones? This equipment would have to conform to UL 60079 versus UL 1203.
At the moment, we're always looking to expand our sales into the North American market. Certification there seems a little bit more complicated than it does for the UK and the rest of the world. So we're always looking at what standards our customers are looking for in the hazardous area North American equipment. So suggest you probably drop us an email offline and we can have a discussion and see how we can help you.
Super, hope that's gone somewhere to answering your question, Trevor. Another question, in the world of advancing technology, can you use Wi-Fi or Bluetooth to switch lighting?
You can certainly use Wi-Fi and Bluetooth to switch lighting, certainly in commercial lighting fittings. It's starting to come to hazardous area light fittings now, so maybe in 3 or 4 years' time, that would probably be the norm. A couple of things to point out is with Wi-Fi, quite a lot of sites that hazardous area equipment is on are industrial sites with lots of steel beams, which aren't very good for the Wi-Fi signal. But certainly something that we have been working with at Raytech, sort of looking at what's available and doing some pilot systems. If anyone does have any applications where Wi-Fi or Bluetooth enabled lighting is required, get in contact with us and we can go through where we are and if it's going to be suitable for your requirements.
Super, thank you very much. At the minute, that does conclude the questions that we have in. We'll hang on another 2 or 3 minutes to see if any more questions arise. And if not, we will close the session. It's not looking like there's any more questions, so At that then, I will like to take this opportunity to thank you for attending on behalf of myself and Barry Thompson. And obviously, if you've got any questions further to this, which you think of after the event, please email us in, either to the marketing email you can see on the screen, or if you have a LaTeX BDM that you're in contact with, get in touch with them, or there's the sales@latexled.com general email address. Thank you for your attendance and look forward to seeing you on the next webinar. Thank you.